Hello friends, I am Hemnath from second year cyber security department studying in Savita Engineering College. Now we are going to discuss about the topic JK flip-flop using Quartus to prime software. Now we are going to create a new project. I'll name the project name as JK. Then we have to give next. We have to give the same name for the file too, which is JK. Then we have to proceed to next. In design entry, we should select the precision synthesis, and in simulation, we should select the model sim. Then we should give next. Then we should give finish. Once after we are proceed with finish, we could see the file over here. Now we should open the Verilog HTML file. Now in this line, we could see that it defines a module named JK with inputs JK and clock and outputs Q and Q bar. Then we have given the input as JK and clock as inputs. Then we declared output with REG since they are assigned in the always block where the outputs are Q and Q bar. Then we initialize the Q as 0 and the initialize Q bar as 1. Then we have given always a positive edge clock such that specifies that the following block of code runs on the rising edge of the clock signal. Then we are given begin to start the program. Then this line implements the behavior of a JK flip-flop on certain conditions. If j is equal to 1 and k is equal to 0, set q to 1. If j is equal to 0 and k is equal to 1, reset q to 0. If j is equal to 1, k is equal to 1, then it is toggled q. If j is equal to 0 and k is also equal to 0, then there is no change in q. Then this line decides that sets q bar to the inverse of q. Then this end module marks the end of the module definition. Now we are going to run this program. First we have to save the changes which we have made. Save. We could see the compilation over here. Once after getting this information, now we are going to open the RTL view of this program. Tools, Netlist Viewer, RTL Viewer. Here we could see the RTL view, which is the diagram which we have got for the program. In this, JK and clock are the input signals to the JK flip-flop. The logic gates are used. Top AND gate does J and not Q. Bottom AND gate does uh, not K and Q. OR gate combines both J and not Q or not K and Q. This calculates the next values of Q. Then the used flip-flops are of two types, D-type flip-flop registers. One stores Q main output and one stores Q bar complement of Q. Clock control. Both flip-flops updates their values on the rising edge of the clock signal. The current value of Q is used in the logic gates to compute the next value. Outputs are the Q and Q bar. Q is the main output from the first flip-flop. Q bar is the inverse of Q stored in the second flip-flop. Now we are going to see the waveform diagram for these equations, this program and this diagram. First we have to go to new university program BWF, and we should right click on this page, insert node or bus. Then we should select node finder. Then we should select list. So our input and output will be listed here, which we have to give on the selected nodes. Then we have to give OK. OK. Now we could see the input and the output. The input and output can be of any combinations. Now I'm going to give us 1, 0, 1, 0, 1. Zero one. Now I'm going to select this one as one with the frequency of 100, which has 0 1 0 1 0 1, and I'm going to give the clock signals as entire one. Once after finalizing the inputs, we should run this waveform diagram. We have to save the modified changes. Here is the output which we have got for the Q and Q bar, where we have got Q as 0 and Q bar as a 1 as the output values in the JK flip-flop. And these JK flip-flop are used in many circuit timers and controls. Thank you.